Hey everybody, in this video we are solving another rational equation. This one will also become quadratic. So the first thing we're going to do is we're going to clear out our denominators by multiplying through by the lowest common denominator. Now this part over here is not prime and it is not factored already. So if I factor it, you'll see I get x minus 1 times x plus 1. These denominators already appear in the problem. X minus 1 is right there and x plus 1 over there. So my lowest common denominator will be the product of x minus 1, x plus 1. So that is what I'm going to multiply everything by. So I put a little note here that this becomes quadratic, but I will erase that to make a little bit of room. That was just a little bit of a warning, or to put it on the thumbnail so that everyone knows that that would happen, so that if that's the kind of example they're looking for, they could find it. So let's go ahead and work on this. So I'm going to multiply through by my lowest common denominator, which, like I said, is x minus 1 and x plus 1. Again, for the 47 bazillionth time, by multiplying through by this, I am clearing out my denominators. So right here, x minus 1's cross out. What is left? Negative 4x times the quantity of x plus 1. Then plus 4. I'm going to distribute over here, right? So that's going to multiply right there. And the x plus 1's will cross out. And then the 4 will be left to multiply with x minus 1. And then we have equals -8. And lastly, we're going to distribute here. However, in this case, because both those factors are in my denominator, I will only be left with -8. So now I have a polynomial equation. This one looks like it will become quadratic and likely stay quadratic. Whereas in example 1, we had one that appeared quadratic, had 3x squared on both sides though, and those cleared out. So I'm going to open this up a bit, multiply it through, get it in standard form, and see what I'm working with. So I have -4x squared minus 4x plus 4x. So instead of writing it there, I'll write it under here, plus 4x. Then that's going to be minus 4. And then I'll bring that -8 over by adding 8 to this side and equals 0. That leaves me with -4x squared. That's gone. And that would be plus 4 equals 0. Now I have a cute little quadratic. If you do this, okay, I'm gonna write a note. Do not recommend. Wait a minute. Recommend. Is that 1C or 2? I'm gonna double check because I'm not sure. I think it's 1. Yeah, it is 1. Okay. You know, sometimes there's like a sneaky second letter. I didn't want to be wrong. So, so I do not recommend to do this, but if you do -4x squared or -4x squared equals -4, divide by -4, x squared equals 1. And then solving from here, I don't recommend this. Why? Because people will take the square root and they'll only get x equals 1. But really, you should get two answers, positive and -1. So I don't recommend doing it like this. So the people, oh, I won't forget to put the plus minus. I'm so good and responsible. Yeah, sure. We all are. Great. I'm proud of you. But guess what? If you factor out the -4, I'm left with x squared minus 1. If you solve by factoring x plus 1, x minus 1, it's like impossible to screw it up, you know? So this, like I mentioned before, is a constant. It can't equal 0. If I set this factor equal to 0, I get -1. If I set this one equal to 0, I get +1. So you can't mess that up if you solve by factoring. So here, everything looks lovely. I get two answers. However, in the beginning, did we state our restrictions? So let's look at our original problem and what the denominators were, right? In the original problem, I had x minus 1 and I had x plus 1. So that means x cannot equal 1 and x cannot equal -1. So I have my restrictions right there. And then wait a minute, x can't equal -1, x can't equal 1. So what does that mean? That means no solution. Both are extraneous. And that happens sometimes. Sometimes, no one's extraneous, right? Sometimes everything's fine, everything's great, whatever. But in other cases, sometimes both are extraneous and it can happen. So here, there's no solution, empty set, whatever you want to call it, right? And that's it. That's the example. That's the end of example 2B, chapter 1, section 6. And we will be moving forward with some work rate problems, something more interesting than what we saw in the last unit. So hopefully you enjoy. I will see you there. Check the description box for the playlist or check the playlist thumbnail on the screen, whatever you prefer, to find what it is you are looking for. Okay? That's it for now. Adios.